tab on Blackboard. If you go into chapter 2, it'll be the last thing that's posted in chapter 2, and there'll be a blank exam and the answers. So let's take a few minutes and look at the ANE. Send it to OneNote so I can write on it. Here 130. I don't think time was an issue on the test. Everyone seemed to be able to complete their ones. There was a couple disappointing blanks. You know, on a 12-point problem, if you leave that blank, there's not much I can do. And on some of them, I was a little harsh on if you didn't even start it right, you're not going to get any of the points. And then some of them, I was like, okay, you did the composition wrong, but from that wrong composition, you got the right domain. I was trying to be somewhat flexible. So the exam, find the values of x for which g of x is -4. So where does g of x equal -4? So I want to know the output at -4, which happens at x equals -4 and x equals 4. So both those, one of those gave you the correct answer there. G of -2 is 2. So where if I plug in -2, what do I output? I output 2. So these were, you know, straight from Wiley. This is a different course, sorry. Wiley's my online calculus homework. These are straight from Alex. I almost said my math lab, which is a different class. These are straight from Alex. Most of these, some of these aren't. Some of these are kind of more what we talked about in class. Number 2, a lot of you just kind of wrote this and didn't simplify it correctly, or some of you wrote 4x squared minus 5. But if you're plugging in 4x, you have to square the 4 and the x. Some of you did some crazy stuff where you came up with 4x times 4x, which was great, but then you did something crazy and got like 2x in the middle or 8x in the middle or something like that. But 4x times 4x, this is the placeholder, and if I'm squaring it, that's 16x squared. So again, 7 points. It could be kind of a kicker. You didn't do that correctly. Math errors here. If I plug in 3, some of you dropped the negative. Some of you did some crazy things here. 2 times 3 plus 4 got like 16. I don't know. And then -2 over 5 would be simplified. Any questions on that first page? This page, again, was painful with the partial credit. Ideally, each one was worth 9 points. There's really only 2 things to do on this problem. So the first thing is to know the square root function looks like this. Then to move it to the left 3 units. And then reflect it about the x-axis. Right. Again, I try to give partial credit here and there. I try to be consistent. But it was kind of hard to judge with 9 points how to go about doing that. B, I saw some crazy things here. You could always plug in points. So if I plug in 0, I get 0. If I plug in -1, I get 1. If I plug in -2, I get +2. Some of you guys had some crazy things other than like this absolute value. Some of you extended it, so you lost a point for extending it. But from x equals 2 to the left, I have that absolute value shape. And then from 2 to the right, x is greater than 2, I have 3. This originally said 2, but I changed it to 3 before I printed it. You don't keep going here because this absolute value function only makes sense for less than 2. So I don't keep going because it wouldn't make sense after 2. After 2, it's just a constant function. And I wouldn't extend it because that would fail the vertical line test. It wouldn't be a function anymore. I have a closed circle here and an open circle here. And that's the constant free function. If you came in, that's all right. I'll start it. What's your last name? So you can kind of break it down into categories if I'm on this side of 2 in the absolute value. Okay. So you see how that absolute value shape just kind of holds true, and it's only to that region there. And then on this side, it's just a constant 2 function. Yeah. It just keeps going. Yeah. Question. So from 0 to 2? So these are just plug-in points. So if x is 1, what's the value of the function? 1, right? So 1, 1. If x is 2, since it equals 2 here, this would be a closed 2, and I just connect all those dots. So on piecewise, anytime you're graphing, you can always plug in points. So that's kind of why I was a little harsh on it. Yeah. So I think you plugged them in for both. So a little harsh on the grading because some of you had graphs like this when you should have plugged in what happens at 3. At 3, I'm minus 9 minus the square root of 9, which is minus 3. So at 3, I should be down here. Right? So I know this is not right because I plugged in that point. And anytime you're asked to graph, you can kind of do that and say, okay, well, what happens at 0? 0, I'm minus square root of 3. At 1, I'm minus square root of 4, which is minus 2, right? At 2, I'm some square root, but it's still negative. Everything's negative. And that's the negative out in front. Everything's negative, so it should be below the x-axis. So
the only thing that you there is you're working with the x clustering, and don't we do opposite of x clustering?
So it goes to the left. Yeah, and so you went this way.
Yeah.
But so this is the basic square root button.
Yeah.
I mean square root function. If I move it to the left 3 and then flip it about the x-axis, it would be this way. Because the negative tells me I flip it about the x-axis. Yeah.
I just made it.
Yeah, you just decided to go that way. And if you plug in a point, if I plug in 0, it should make sense. So, you know, part of the purpose of giving you exams as we go, ideally, is like to show me you understood everything and you're 100%, but that's not always the case. So the exam is a learning tool as well. So here's where you're at this exam. This is what I need to make sure I don't do on the final. So the final's not until May, which is a ways away. So this is a good thing to keep. And when we get closer to the final exam, bring it out. I posted on my math lab, my Blackboard. On Blackboard, I posted a blank one and the answer key. So as we get closer to the final, print off the blank and take it. And then look at the answer key and compare what mistakes did I make back when I took the exam, what new mistakes did I make, and how can I fix those before I go to the final exam. Yes, those are yours to keep. Question. I am just kind of going over it. So we are on page 2. Number 2? Yeah, so the answer, did you have 4x quantity squared minus 5? So you missed the point for simplification. You didn't put 16x squared, or 2 points, or 3 points for simplification. Yes. So here's the way exam works, or the way that I kind of give my exams, I put floating bonus. So out of 100 points, or out of, really there's 104 points. If you add up all the numbers, 6 points, 7 points, 7 points, there's 104 you can, if you don't miss anything, you're going to get 104 out of 100. So then I take off those points and I give you those 4 bonus points back. So that's why everyone's grade seems to be curved 4 points, is because those are the floating bonus. Question? On the first page? Okay, well, we'll get there. Yeah. So does that kind of make sense? And I try to do that on all my exams. That way, if something's worded weird, or, you weren't anticipating the way that's going to be, that way I just kind of saves me. It's like, those are bonus points then. So again, I understand you guys do a lot of homework on Alex, so I try to give you Alex-like problems as well. So this is one, can I shift this to left 3 and down 2? You don't have to come up with your own graph. You shift it to the left 3 and down 2, and you come up with this answer here. Question? That's all right. This one here can be done multiple steps. So the first thing I want to do is, since it's f of minus x, that means all the x values then become negative, but I keep the same y values. So this value from minus 6 becomes positive 6, but the y value is the same. Right? So this red point gets transformed to this blue point. This red point is at positive 3 minus 1, so then it becomes negative 3 minus 1. Right, and then this point becomes this point. So in the original function, the blue function is now f of minus x. Then I shift that down 5 units, and I get, go ahead and put it in purple. Every point gets down shifted, and that's going to be f of minus x minus 5. The purple one. So some of you would flipped it this way, and that doesn't really make any sense. There's no formula there to get it to flip that way. But you saw that minus x. So the minus x is saying I'm inputting x values. So this 3 that I'm inputting, I'm really inputting minus 3, but I'm getting the same thing out. So this point becomes over here. This point comes over here. This point comes over here. This point comes over here. This point becomes over here. So it's a reflection about the y-axis. You can think of that as well. And these are posted online. So if I'm drawing some crazy things on here, it is posted online. And this is the correct answer here. Make sense? 6, is it in the domain? Yes or no? Some of you put no on minus 5 because the denominator can't equal 0, but the denominator doesn't equal 0. Minus 5 squared is 25. 25 plus 25 is 50, not 0. So there's no problem here. Minus 8, there's no problem because I can take the square root of 0. And minus 10, there's a problem because I can't take the square root of minus 2. That doesn't exist. Do you guys see that now? So some of these will, possibly show up on the final exam, but they might be worded differently, but the exact same format. So a lot of the ones you will see as we take the hours exams are going to show up again on the final exam, the exact same form and format. The problems will be just different. So we'll have a different formula here. Maybe it's going to be x squared minus 25. Then again, this answer would be that it wouldn't be in the domain, but it's going to be the same form. Question? Mm-hmm. Yeah, you can. You can just say square root of minus 2 doesn't exist, so it's the output. So yeah, you could also say you can't take square root of a negative number. Yeah, if you wrote it out, that's fine too. That's what I'm looking for though. This is the square root of a negative number problem. So the denominator, I don't have any problems anywhere. I can plug in any number there and not have a problem. This page was actually really good. A lot of people didn't miss anything. If I'm plugging in -3, 5, 21, 7, 20, that was, does anyone have any questions on that? Number 8? Yeah, but on piecewise, no. Number 8, there was 2 parts to number 8. The first part was to find the composition. And so there's 2 ways you could go about it. You could plug 2 into the f function and get 11. Right? 2 squared plus 7, 4 plus 7 is 11. Then plug 11 into the g function and get 2 times 11 plus 3, which is 25. You could have wrote out the composition. You could have said, what is g of f of x? And that would be 2 times x squared plus 7 plus 3. And then plug in x equals 2. I don't think anyone did that, though. So did you do that? Did you do it and you got 25? Yeah. Yeah, so you end up with 2x squared plus 14 plus 3, which 2x squared plus 17. And if I plug in 2, I have 2 times 4 plus 17, which is 8 plus 17, which is 25. Okay, but you got 25. This is kind of the long way to go about it. You're coming up with the formula, and then you're plugging 2 in the formula. You can just plug 2 into the inside function, get out a number, plug that number into the outside function, and get out your answer. Here, this is asking you to find f of g of x. So your inside function is g of x, and your outside function is f. Right? So if I look at my outside function, I'm plugging my inside function everywhere I have an x. So I have 2x plus 3 quantity squared plus 7. So we had to square that out, and we came up with this answer here. Now, some of you just factored out of the 4 and then made it disappear. Yeah, it's like,
So
not, you still need it. You don't have to. This is what I want you. If you would have left your answer here, you lost points because it's not simplified. Here, you got full credit. A lot of you wrote this next step, but you didn't put a 4. So it took me a while to think, what are they doing? Why do you just disappear 4? It has feelings. Yeah. It's off by a factor of 4 though. So it would be the same thing if you kept the 4 there, just pulled it out front. But that also happened on the next page too. This one, again, 8 points. If you didn't do it, you got 0 points on this. This was this was a Alex. It's an Alex problem, and we also went over it in class. And so it was, if you knew how to do it, you got all the credit. If you didn't, you put some crazy stuff and lost 8 points. So, yeah. The approach to this, like I said before, is I'm looking for the composition of G composed with F. So F is my inside function and G is my outside. So I start with F. 1 goes to 0, 0 goes to 1. So 1 and 1. 1 is in the domain and 1's in the range. 1 goes to 0 and 0 goes to 1. So 1 is what I start with, and I output 1. Then I say 2 goes to 7. There's no 7 here. So 2 cannot be in my domain, math anywhere. So 2 is not in my domain. 3, 7, there's no 7, so 3 can't be in my domain. 5 goes to 2, and 2 goes to 1. So I can add 5, because 5 maps to something in the range of g of x. 7 goes to 9, 9 goes to 1. So 7 is in the range. 1 is still, sorry, 7's in the domain. 1's the only thing in the range. 9 goes to 7. There's no 7 to map anything to, so 9 can't be in the domain. So 1, 5, and 7 are the only thing in the domain of this composition, and 1 is the only thing in the range, because 1, 5, and 7 all get mapped to 1. Question? Mm-hmm. Mm-hmm. You put, yeah, the inside function and the outside function. So the f is the inside function, right? So if I have all my x values that can go inside in my inside function, I like to say first and second because is this the first one or is this the first one? So I usually say inside, outside, just to be consistent. Inside function. So that's what I look at. What can I put into my inside function? 1, 2, 3, 5, 7, and 9 are what I can put into my inside function. From there, how does that get mapped to my outside function, which is the g? This is the g. Put in something in f, it outputs something. I put that output into g, and then it maps me somewhere else. And this was on Alex, right? So yes, I pulled it up. So this was on your homework and probably on your pie. So everyone had exposure to this problem. I told you, I guarantee there'll be a difference quotient on there, right? 100%. This will be on the exam. This will probably also be on the final exam. This is an important part of college algebra, but super hard grading it when things went terribly wrong for some of you. We did a couple of these, right? This x plus h quantity squared, x squared plus 2xh plus h squared. Factor that 4. I kind of told you what to expect. These two terms had to cancel. So canceling them, I'm left with these two terms. I have dividing by h. I factor out an h in the numerator, and I get this as my answer. And some of you said 4 is evil, and I'm going to pull that out. So the answer is 2, or the answer is 8 plus 2x. Yeah, 2x plus h. So I don't know why that happened. But... oh, yeah. So I try to kind of gauge where some of you maybe left out a 2 here. And usually it didn't cost you too many points, but it was the ones that just had nowhere to go was 12 points, which was kind of killer. The letter grade. Number 11. Some of you, I tried to look at your domain based upon your composition. So this is 8 points, and I try to give you 4 points for composition and 4 points for your domain. Different ways you could write your domain. I accepted x cannot equal 2. I really wanted minus infinity to 2 union 2 to infinity. Some of you put 2 to infinity, and I tried to say, okay, there is also another side. It just can't equal 2. Mm-hmm. Mm-hmm. If it had a square root, you wouldn't know because you can't take a square root of a negative number. But this one has nothing to do with negative. The denominator can be negative. So here I try to gauge, okay, you understand it. Any other number in the world except x cannot equal 2. If this was a square root, then of course you would take that out because it can't be negative. Question? It's a good question. Okay, there, you're my person that did this, right? I don't know. I want to cry when I see it. No, only when you're multiplying. If I would have had like a times b over a, I can cancel a. But you can't cancel if this was a plus b. There's nothing to cancel there. That's a common just algebra mistake. Some of you, also x minus 3. Some of you are going to replace the x with the function here, but not in the denominator. So there is just a lot of, like you said, Mickey Mouse mistakes, which is frustrating grading because it's like, it's important, but I can kind of see you did a half right. Yeah, here you had the setup and then you did this, and I was like, not. It's like, oh, let's just divide by 0 and say 5 is the answer. Kind of. Yeah, I try to kind of gauge that in, so this was kind of worth 4 points. This was kind of worth 4 points. And then if you did this totally wrong, you missed 4 points. But from here, if there's a way I could kind of salvage it, I try to give some partial credit there. The last one was just 1 point each. That was screenshot from Alex. So you should have had exposure to is this a function or not. Here's 6 points. Any questions on the exam? If you have individual grading questions, let me know, like, why did I miss 4 points here? I try to keep an answer key, kind of try to make notes. If I took off 4 points for everyone that did this mistake, I'll, be consistent with that. Also, make sure, I added your points up right. I posted this to Blackboard, so you can keep this copy, but kind of go through and if I make a mistake, I want to know now, not 2 weeks after the final. Oh, I should have actually got 3 points on the first exam. Yeah, well, I don't know. I always fear that's going to happen. It's never happened to me at this point, but I want to try to avoid that. So, kind of your responsibility and get it back to me. If there's any problems, let me know as soon as possible. No, it's yours. So you want to keep it and make sure you're responsible for the final exam, being able to pull back up your test and say, oh, I made these mistakes and I learned. Don't keep it. I don't do that. So today we're going to talk about doing 3-2. We're going to spend 2 days on 3-2, but we won't get all the way through this. So 3-2 is going to cover polynomial functions. So we're going to introduce this idea of graphing. So this next chapter will be a kind of a lot of graphing, but there's not a lot of held graphing. It's just kind of like in behavior and where are the zeros. And the polynomial is going to be continuous everywhere. So there's not going to be any problems. There's not going to be any horizontal or vertical asymptotes. You're going to be able to start at a point, do something, and end at a point. There's not going to be any any worries about what happens in between, like rational functions. So key things in a polynomial are the zeros. Where does it cross the x-axis? And also the end behavior. Is it going to infinity or is it going to minus infinity? Does it start from infinity or does it start from minus infinity? We're going to apply the intermediate value theorem and also begin to sketch these polynomials. So this is the definition of a polynomial. This is a polynomial of nth degree. Right? So these a1s are just numbers, or real numbers, and x's are variables. We'll only be able to graph polynomials. We'll only talk about polynomials. This is an example of a polynomial. These are not polynomials. If you have square roots of anything, it's not a polynomial. Cube roots, fifth roots, sixth roots, that rules out a polynomial. If you have any x in the denominator, your power of x is less than 0. So if it's negative, it's not a polynomial. You can't graph it this manner. And then you won't have any imaginary numbers. Right? So this begins with end behavior, and there's going to be 4 conditions. There's going to be 4 different types. The first thing we look at is if the greatest power, we're going to call that n, of your polynomial is even, then it's either going to go both to infinity or both to negative infinity. This is what's known as the end behavior. We don't know what necessarily happens in the middle. So if we look at an example of graphing x squared, if it's even, right? I haven't gotten to the coefficient yet, right? It's going to have to do with the first term. It's going to have to do with the coefficient and the power on n. If the coefficient's positive, then your end behavior is both going to go to infinity. Which if we look at an example of x squared, the graph of that, the coefficient is positive, and it's going to infinity on both sides. A positive number squared is a positive number. A negative number squared is a positive number, right? So the end behavior here is both of these are going to infinity, positive infinity, right? So as I approach infinity this way, I go to infinity, and as I approach infinity this way, I output infinity. Right? You guys see that? If the a is negative, then it flips it around, right? This would be like minus x squared. It would look like this. At this point, we don't care what happens in the middle. We only care the end behavior. So if the highest power n is even, then you look at the coefficient on that term. If that coefficient is a positive number, they're both going to infinity. If that coefficient is a negative number, they're both going to minus infinity. And if you're not sure, you can always think, oh, let's just look at an example of squared. Minus x squared. This is going to work for any general case where the power of the highest term is even, right? So x to the 54th is going to go, you don't know where, but it's going to look like this at infinity and at minus infinity. This is my x-axis. The end behavior is going to look like this. Get to that? If it was minus 6x to the 4th, you don't know there, and it's going to go to minus infinity on both sides. If n is odd, then we can think of x cubed, right? That's the graph of x cubed. You think a positive number cubed is a positive number, right? Positive times positive times positive is positive. A negative number cubed is negative times negative times negative, which is negative, right? So we kind of have a graph that goes like this. Do I see that? And if a is an, the first leading coefficient of that highest degree term is negative, it just switches it. And if you think this way, this way. You can plug in any really large number, it's going to be negative. I have negative 5x cubed, right? And I plug in x to be 100. 100 times 100 times 100 is positive. But when you multiply that by that negative 3, it makes it negative, right? If I plug in minus 100, I have minus 100 times minus 100 times minus 100 times minus 3, which makes it positive. So there's going to be 4 things that can happen, right? Both of them are going to be positive. Both of them are going to be negative. The one on the left is going to be negative, and the one on the right is positive, or the one on the left is positive, and the one on the right is negative. We only care about. So let's look at an example over here. So what is the end behavior going to look like? Up or down, right? So I don't necessarily know what's going on in the middle, so the end behavior is going to be both down. What about in this case? Up to the left and down to the right. What is my leading coefficient? Minus 6x to the 5th. Because all I care about, so this is x, this is 3x cubed. This is, oh, so not minus 6, sorry. What would 3 cubed be? 27. So 2 times 27, 54. So minus 54. And then x times x cubed times x, which would be x to the 5th. So I don't have to expand all this out. I just care about the leading coefficient, the highest degree term. So I have this minus 2. The rest are all positive, right? 3 times 3 times 3, positive number, times a negative number. All I care about is it's negative. I don't care really what it is. That is just a negative number. Then I have x times x times x times x times x. So x to the 5th. Okay, see that? Look at another one. Let's look at q of x. I have a negative 5 times x to the 4th times a minus x cubed times a 2x. Really, if I just care about the x terms, the highest power in each parentheses. Negative times a negative times a negative is negative, times the negative out front is a positive. Right? So this ends up being 5x, 10, sorry, 10x to the 8th. Right? Really what you have to do is say is look at the sign on the coefficient, positive or negative. The sign on the coefficient here is minus. The sign on the coefficient here is minus. This minus is to the 3rd power though. Minus times minus times minus times minus times a positive is positive overall. You guys see that? You're playing with, this is the leading term, and this parentheses, this is the highest power of x, and this is the highest power of x. So I have 4, 5, 6, 7, 8. So I have a positive a times x to the 8. I don't really care what a is. In this case, it's 10. But I just care if it's positive or negative. So what would this look like? Up, both up, right? Okay, see that? What about this one? Yeah, it's already done for you, right? Just looking at these, what is your favorite one? This is your favorite one? It's not factored, so it's easy to see that leading term. However, when we talk about zeros, these are going to be your favorite ones, because these are really easy to see where it equals 0 at, because they're already factored. So it equals 0 at -4, at 1/3, and at -5. Here, this is a 5th degree polynomial. You're going to have to do long division to factor that. And we'll get into the rational root theorem and long division in this section. But I ask you this now, and everyone's like, oh, this is my favorite. I ask you in a week, you're going to say, nope, I want to see them like this. So that's why we present them this way, is because if I give it to you factored, they're a lot easier to graph, because the zeros are right there. You know exactly where it's going to cross the x-axis. So eventually you're going to say, okay, it crosses the x-axis here, here, and here, and the end behavior is positive. So I'm going to sketch this, you know, something like this. And we'll talk about even and odd multiplicity, but eventually that's where we're going to, is coming up with this rough sketch of these functions. So if we need to know the end behavior to kind of begin that. Which leads us to touch and cross points. So I'm going to cross the x-axis where I have a 0 in my function. This is where I cross the x-axis. This is a 0. If the power, like you see here, this is a multiplicity of zeros. It has a power of 3. This has a power of 1. This has a power of 4. You guys see that? On the zeros. If you have a 0 and it has a odd multiplicity, then it's a cross point. It's going to have to go through the x-axis. If it has an even multiplicity, it's a touch point. Intermediate value theorem has to do with we cross the x-axis or if we just touch it and go away from it. So if my end behavior looks like this, and I know I have to cross the x-axis at 2 points, I know I have to touch one and go away from it, because if I went like this, I have to have another 0 there. And if I know I only have 2 zeros, then one of them has an even multiplicity, it's going to look like this. You see where the multiplicity on the zeros tells you, does it go all the way through the x-axis, or does it just go to the x-axis, touch it, and go away from it? So we're trying to kind of decipher all this information from a function without actually plugging in points and graphing it. We want to just know the interesting points. What's the end behavior? Where does it cross the x-axis? And then from there, we're done. One extra step in calculus would be to find the maximum point, but we're not going to worry about that. We're going to just focus on where does it cross the x-axis and the end behavior. Once we know all that, we just connect the points. And if it's an even multiplicity, then touch the x-axis and go away from it. Stay on the same side of the x-axis. If it's odd, it's going to go all the way through it. So from this graph, if I was to give you this function and ask you to graph it, I know my leading coefficient is negative, and I have an x to the cubed. So I know my end behavior looks like this. I also know 0 is a root, or 0 is a 0 of the graph, and 4 is the graph. So I plot those points. Now, if I want to connect this arrow to this and cross these points, I'm looking at multiplicity to see if I cross the x-axis or if I touch it and go away from it. So this has a multiplicity of 1. It means I cross it. And then I have to approach here. It has a multiplicity of 2. It means I touch it and go away from it, and then I can connect my arrows. You guys see that?
What do you mean?
A 0 is where the function equals 0. So where does this equal 0? We use 0 multiplicity. A times b equals 0, then a equals 0, or b equals 0. So here I would set this term equal to 0 and this term equal to 0. So if I plug in 0, my function is going to if I plug in 4, my function is going to equal 0. So those are my points on my graph in which I know the function crosses the x-axis. Let's look at this z of x. These are all simple multiplicities, right? They all have the power 1, and they won't write the power 1, it's understood. Like q of x, they tell you 4, 3, 2. Right? So where are the zeros at here? Yeah, so to find the zeros, I have to say this equals 0, or this equals 0, or this equals 0, or this equals 0, or this equals 0, right? So x equals 0 at x 1/5, 8 over 3, sorry, minus 8 over 3, square root of 5, and minus square root of 5. That's by taking when does 5x minus 1 equal 0, when 5x equals 1, when x equals 1/5. You guys see that? It's just solving for equals 0 in each one of the parentheses. Because if one of these parentheses equals 0, the whole thing equals 0. Then what's my leading coefficient? X times 3x times 5x times 4x. So we have 60x to the 5th. So that tells me my end behavior of my graph is going to be like this, right? Because it's positive, it's x to the 5th. Does that make sense? The positive number. Then I plug in my zeros. I know I have a 0 here, a 0 here, a 0 here. Square root of 5. What's 8 over 3? Which one's larger? 3. Yeah. 8 over 3. Square root of 5. Square root of 9 is 3. The square root of 5. Square root of 4 is 2. So between 2 and 3. What's 8 over 3 though? Minus 2 something. So this might be a good one for, calculator. I have 2 on the negative, I have 0, and I have 1/5, and I have square root of 5. Yeah. Minus 8 over 3. Yeah. Okay. So these are all simple roots, so it turns out it doesn't really this point matter because I'm going to cross every single one of them, and I'm going to go back through the x-axis. One of these all of a sudden had a multiplicity of 2. That's going to change. Instead of 60x to the 5th, it's going to be 60x to the 6th, and then all of a sudden I have to look like this, and I couldn't cross each one of them and end up also going to infinity. So one of them I have to touch and go away from it. One of them I'm going to have to go like this to end up back at infinity. So we'll spend some more time on this on Wednesday and kind of get down to being able to look at where the zero's at, which